Alright, so digging into 41 here, we're just expressing the first function as the second, so we're trying to change tangent into cosine. So just tangent equals sine over cosine, right? Not too tough. And then 46, cosecant into cotangent. So we have to take cosecant and change it into sine first, and then from there change sine into something with tangent in it, right? Let's see, I'm moving quickly through all these steps, but I'll go back and just kind of explain. So sine here, remember tangent equals sine over cosine. So if you solve that little formula to equal sine, sine equals tangent times cosine. Okay, so that's why I replace sine there with tangent times cosine down here. Okay, and then from there, I just go ahead and circle that blue part because 1 over tangent is the same thing as cotangent. So now I have cotangent times, well, 1 over cosine. So it's cotangent over cosine. And that's what we wanted, was it in terms of cotangent. So now we have cotangent in there. Cool. All right. So let's see, we're going to do 48 here. And they want us to go ahead and find the values of theta. The only way I know to do that is with arctangent. Like you can plug it into your calculator. You can find the arctan of things. That's the only way I know to do of it. So you plug in an arctan of 4 over 3 into your calculator, and that gives you the theta. So that's the only way that I know how to do it. There might be a different way using properties and things like that, but I just don't know because I haven't looked at your book well enough, looked at the chapter. So anyway, number 57 here, moving on. Let's see. So 57, basically, we're going to go ahead and find the area of a triangle with the given description. So we're finding the area of this triangle with the sides length 7 and 9, and it has an angle in between them of 72. So this is our formula, right? We have, this is just kind of how it goes. We have A times B, which are those two sides, and then the sine of whatever that angle inside there is, in this case 72. So 7 times 9, sine of 72 over 2, and you can just use your calculator for that. Just plug it on in, and everything should be good. Just remember to make sure your calculator is in degrees, not radians. Okay. All right, so moving forward, we have number 64 here. Kind of similar. We're going to use that same formula. So that angle in there is pi over 3. So first we're going to want to convert pi over 3 into degrees because our formula is only in degrees, right? So we need to convert it into degrees so we can put this thing in our formula. So converting it to degrees, we just do multiply by 180 over pi. Those pi's go ahead and cancel out, and we get 180 over 3, which is just what? 60, I believe, right? Okay. So they told us that those two are 12, right? And I think I missed crossing off. There we go, cross off that last section. So the area here, we just need to plug it into our little formula. It's both sides multiplied times each other. This time it's 12 times 12. And then the sine of that angle on the inside, remember that we just converted that to 60. So go ahead and plug that into your calculator and solve that, and it should be pretty straightforward. And if I remember correctly, I think the sine of 60 is, let's see, radical 2 over 2. So that helps. You could just kind of plug it in from there. Anyway, 66 and 68. Unfortunately, I need more information from your book. 66 refers, I think, to the problem right before it, or possibly 68 does. Either way, I need more information from your book in order to do this. I just need to know, some more things. There's stuff that is missing that I don't know, that I can't solve it because of that. So, moving on to the last problem, or I guess I should say last two problems, 71 and what is it, 72. So 71, I go ahead and right off the bat, I convert this problem into terms with cosine and sine, right? So cotangent is the same as 1 over tangent, And tangent is the same as sine over cosine. So cotangent is just the flip of sine over cosine, which is cosine over sine. So that's why I have rewritten that right here. And then over there it says cosecant. Cosecant is the same thing as 1 over sine, so that's why I'm rewriting all these things up here. This way we can go ahead and put this stuff into our calculator and actually go ahead and graph it. So now we have everything in sine and cosine, and we can go ahead and graph it. In this case, instead of like y equals mx plus b, we normally put an x. This would be like cosine of x, or cosine of theta, right? So then for b, we can just find the max in that graph. So we'll graph it in our calculator, look at what that maximum is, and boom, done right there. 72 is very similar. I just go ahead and right off the bat convert everything. So cosecant is the same thing as 1 over sine. So I'm just changing that. And then secant is the same thing as 1 over cosine. So I just changing this stuff here. Rewriting the problem in terms of sine and cosine so that we can go ahead and put it into our calculator to graph it. And now you just click the graph button, the functions, and for your function you can put in literally 9 over sine theta plus 6 over cosine theta. Maybe instead of theta you might have to use x or something along those lines, right? So that your calculator knows what to do. But then we just find the minimum on that graph, and it makes sense, right? If the pipe was any bigger than whatever that minimum is, then, well, it wouldn't be able to fit, right? Okay, good deal. So that wraps up 6.3. Let me know if you have any questions on any of 6.1, 6.2, or 6.3.